I'm live, right? Can I start now? Can I start now? Dear students, welcome to the first live session of the course Solar Energy Engineering and Technology. So far, we have covered 4 modules. We'll briefly discuss what are the content we have covered so far. In module 1, introduction to solar energy was discussed. In module 2, solar radiation geometry was elaborated. In module 3, solar radiation estimation was discussed, and in module 4, solar photovoltaic systems were elaborated. So in lecture 1 of module 1, primarily energy scenario has been discussed, which includes definition of energy, what is the need of energy, what are different forms of energy. Then we have discussed about world's energy scenario, what are different routes of exploiting solar energy, what are the different methods of energy utilization, what are the different devices for thermal collection and storage, working of PV generator, then the concept of solar power plants. So all these basic informations were discussed in this lecture. In lecture 3 of the same module, primarily we have elaborated about the physics behind of propagation of solar radiation from sun to earth. That means what is extraterrestrial region, what is earth atmosphere, then what is terrestrial region, then what happens in the earth atmosphere when solar radiation comes and striking this earth atmosphere. That means how this solar radiation is propagated, how this scattering happens, how this absorption happens, what are the gases responsible for absorption, and what are the gases and what are molecules or maybe no dust particles are responsible for scattering. These were elaborated. And of course, sun-earth relationships were discussed, and different kind of radiations, like what is normal radiation, what is diffuse radiation, and then if you combine normal and diffuse radiation, what you will get is global radiation. Also, we have discussed about air mass. What does it mean when we say AM0? That means radiation above the earth atmosphere in the space. And AM1 is when solar radiation is on the overhead, that is at the zenith. So this AM is defined as 1 by cos of theta. So when theta is 0, then what you will get, AM1 is 1. And accordingly, we can find out what is the angle at AM is equal to 2 or AM2. And AM 1.5 we have discussed at the end, because this AM 1.5 is very, very important. And at this AM 1.5, normally solar modules are tested. And of course, solar radiation has to be 1000 watt per meter square. And other parameters are of course need to be considered. In the lecture 1 of module 2, primarily we have discussed about the concerns of solar equipment designers. Say for example, if the work has been given to an engineer to predict the radiation for installing some kind of device, so it is very difficult to design without knowing its earlier data. Okay, so what they do, first they will look for some kind of data of the particular locations. If data is available, then well and good. in the form what is required by the designer. If this data is not available, then what that designer can do, he can see the other locations similar to the same climatic condition of the place where he has been asked to do the analysis. So once he has confirmed about the radiation spectrum and other weather conditions, then he can take the data and do the analysis. If these are not available, like similar kind of no data is not available and he couldn't manage it, then the designer can rely on the models developed for different conditions for estimations of diffuse radiation and global radiation, and of course normal radiation will be there. Then the instruments, what are different instruments used for radiation measurement? Say primarily 3 radiation instruments are used, like we have pyranometer, which is used for measurement of global and diffuse radiation, pyroheliometer, which is dedicatedly used for measurement of normal radiation, and then sunshine recorder. The sunshine recorder give the brightness of the sun. That means how long the sun radiation was bright in a particular day. Then we have discussed about units of radiation. What are different units, like kilowatt per meter square, kilojoule per meter square hour, and then Lagrange. So different units what is used for solar radiations have been discussed. Then of course solar radiation data, that means how this radiation is propagated. So if you consider a very clear and sunny day, then what you will get? You will get the peak at the solar noon, and then it is decreases. Of course, it is starting with, say for example, at 6 o'clock. If we start slowly, it will increase, and then it will reach a peak, and then it will reduce the value of the radiation. But if we consider a day having a lot of clouds on the sky, then we can have a lot of peaks and valleys. So under that condition, it is very difficult to predict or suggest what kind of technology or what kind of solar radiation converting devices could be employed. Okay, so these things were discussed in this class. And in lecture 2 and 3 of module 2, solar radiation geometry were discussed. What are the different angles involved in defining solar radiations? Starting from we have phi, latitude, then we have longitude, because this latitude and longitude is required to specify a location, and how to define latitude. Then we have delta, like declination. So how this delta is defined. Then we have gamma s, solar azimuth angle. Then we have surface azimuth angle. Then we have theta z, then beta inclination, or you can say incidence angle, or if we consider inclined surface, what is the magnitude of the inclined surface? Those things we need to consider. Then what happens in case of horizontal and tilted surfaces? Then why do you need to learn local apparent time? So this local apparent time is required to calculate this omega, that is hour angle. So these were elaborated with numerical examples, and also we have discussed about the sun path diagram. In lecture 1 of module 3, different correlations were discussed, which were used for extraterrestrial region. Like why the need of correlations, and what are different classification of weather, then the calculation of monthly average of daily extraterrestrial radiation, then different correlations for estimation of monthly average of daily radiation. In lecture 2 of module 3, we have discussed about different correlations for estimation of monthly average of daily diffuse radiation, then global radiation, on both horizontal and inclined surfaces, and of course on cloudy skies and clear skies. And also we have solved sufficient number of numerical problems to strengthen the understanding. In lecture 1 of module 4, solar PV conversions were covered, and primarily there were few things what we have discussed are as follows, like what are the importance of PV conversion and challenges, and construction of PV cells, then manufacturing of single crystal silicon solar cells, then working principle of solar cells. So what is band gap energy, what are the loss mechanisms? These were covered in the first lecture of solar PV conversion. In the second lecture of solar PV systems, primarily we have discussed about semiconductor physics, starting with classification of semiconductors, then doping, then Fermi energy level, then p-n junction, then drift current and diffusion current. How does two currents are defined? Then generation of solar cell materials. All those components were elaborated exclusively. In lecture 3 of module 4, primarily we have discussed about the characterization of PV cells. That means what will be the field factor, what will be the short circuit current, how does VOC, that is open circuit voltage, influences the performance of the solar PV, what is maximum current, minimum current, maximum voltage, then maximum efficiency. And also theoretically we have derived the expression for maximum power which can be extracted from a solar cells. And effect of variation of solar insolations and temperature on the characteristics of solar cells have also been elaborated. And at the end, solar cell efficiency and band gap energy was discussed. In lecture 4 of module 4, we have covered solar modules, arrays, and PV systems. Primarily, we have discussed about classifications of PV modules, then effect of shadowing, packing factor, then module efficiency, what are different ways of maximization of PV module performance, and what is maximum power point tracking, and what are different possibilities for operation of a MPPT, and what is PV arrays, how we can define a PV array, and how this PV array is different than PV cells, than PV modules, and what are different components which constitutes a PV systems. So these were discussed so far, and I would like to thank you for taking this course and for coming for this live session. So thank you so much for your attention. If you have any queries, then you may go ahead. Good evening, Dubey. And Dubey has some queries like question number 4, 5, 7, 8, 9, 10, and 2. Third week. Of course, this solution should be provided to you. Our team in discussion forum, they will update you about the solutions. I'll convey the message to them. Mr. Dubey, you can raise your difficulties. You can know write in the discussion forum. Then we'll help you to solve some of the problems. But these are not so complex. If you see the videos, solve the problems, will help you. Any doubt from other students? So your question is daily solar radiation falling on a horizontal surface and reaching in the horizontal surface. No, what kind of question it is? I'm really confused. See, when you are using those correlations, so first thing, if HG, if you want to find out this global radiation, then you must know what is happening in above the Earth atmosphere in extraterrestrial region. Okay, H naught bar you need to find out. So if it is for global radiation, then it is equal to A plus B S by S max, right? So this S by S max, S max is how it is calculated. It is 2 by 15 cos inverse of minus 10 phi into 10 of delta. So that omega you can find out, sorry, the TS you can find out from that calculation, right? And this is nothing but your S max. And S is given to you like particular day, what is the solar radiation, okay? And H naught bar, you know how to calculate it. It's a long expression you have to use. So that expression will give you H naught bar. And once you know these components, and if you know the particular locations where people have already calculated A and B, then you substitute those values there and then find out what is Hg bar. That is global radiation falling on a horizontal surface. right? So that you can find out. So for example, sometimes what happens, then you can enhance the, or you can increase the complexity of the problem. Say for example, if I say it's an inclined surface and radiation is falling, as you know, when we are can consider theta z, okay. So what is theta z? If you consider a horizontal surface and solar radiation is falling, okay, and what is normal to the horizontal surface is your this way, okay, and this angle will be your theta z, right? Now if you sense this horizontal surface to the inclined surface, so it will make some kind of angle here, so it may be to 15 degree if I consider. Then what happens, two perpendicular things you will get, one is normal to the horizontal, other one is normal to the inclined surface, okay. Then this will be projected in the due south, okay, or south. So this projection, what it makes with the horizontal surface, that is your gamma, okay. So sometimes we say gamma s when it is normal to the horizontal, and that radiation makes a projection on the horizontal surface with the south, okay. So if I consider, say if I give some kind of angle, say this gamma makes an angle of 30 degree with the due south towards west, because towards west will be positive. So that way you can actually increase the complexity. If you read the geometry clearly or carefully, I think there should not be any problem in understanding or solving this kind of problem. Got it? And if you still have some doubts, so please post the informations what you need in the discussion forum. So there actually we can help you how to solve the problem. If any other students have any doubts, please. Thank you, Mahendra. And I suggest if you have any issues, please post in the discussion forum. We'll help you. If no more question is there, maybe we can conclude here. So thank you very much once again for your interest in this course. Hope you have learned many more new things. And of course, 2 more live sessions are there. So in those live sessions, we can further discuss. Okay. So thank you very much.